equilibrium was not okay. Let me start the sentence over. That is not important in this class. It will not be on the test, but it is something that's good to know. Now, this next part, eyes, Kirill. Everyone, okay, eyes, let me see them. All right, great. This next part will be on the test. It is very important that you pay attention. Thank you for being my best man.
No
It means
problem.
a lot to me then. Thanks. This isn't for class. What? What the? Zoe, what's going?
I'm sorry.
You cheated on me? Why, Zoe? Why? How could you cheat on me?
This is Christian Dare, weighing in at 180 pounds, approximately 6 feet, 1 inch.
And a half.
Christian, what's your strategy for today?
Coming into the fight, I've got more mass than Zoe. So I'm going to try and, get my weight behind my punches, my flying knees. I'm talking teeth, nose, eyes, mouth, face, uterus, stomach, chest, wherever. You know what I'm saying? I'm just going to get in there, boom, 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 boom. Hopefully I can knock her down a few notches.
Alright, how's your mass help?
Well, my mass gives me more momentum into anything I do.
Alright, sounds
Everything.
good. Let's go. This is Zoe Weasley, like from Harry Potter. She is 5'3", weighing in at... She doesn't like telling her weight. Zoe, what's your strategy for today?
Can't
Well,
imagine
my
why.
strategy for today is to try to pick up objects to hit him with so I can increase my mass and therefore increase my momentum.
Good job. Let's get ready for this fight. So Lucas, what do you think Christian's strategy for today?
Well, they got physics on their side. As you know, Christian's mass is a lot higher than Zoe's. So that'll raise up his momentum since they're probably going to get about the same velocity. Zoe's trying to increase her mass by picking up the objects, which also would increase the momentum behind their hits.
Alright, thank you. Let's get ready for this fight.
I'ma fight to the end. Let's go. Ain't no way they can stop me now, daddy, cause I'm on my way. I can feel my ring coming. It's the blood of a champion, pumping deep inside my veins. Too much pride to be running. I'ma get what I can and more, even if my blood, my sweat, and my tears don't mean nothing.
Christian was right when he said momentum would be on his side. Right here, we have the conservation momentum equation, just saying how conservation is conserved from right before and right after the collision. Here, the mass times velocity plus the mass times velocity equals the total mass times the velocity. Christian's mass of 81.65 kilograms times his velocity of 3 meters per second, and adding that to Zoe's mass of 54 kilograms times 2 meters per second, and dividing all together by their total mass of 136 kilograms will leave us with 2.6 meters per second for the final velocity, which is saying Christian increased Zoe's speed falling.
Throughout the fight, Zoe had the advantage because of pressure. Pressure is equal to force over area. Christian, why don't you explain how that affected the fight?
Well, for me, I had a big area. And so when you have a big area, the pressure is less because if you just take some random numbers, 2 over 5 is a lot bigger than 2 over 10. So as the area grows, the pressure becomes less. Now Zoe, why don't you tell them about what you had?
On the counter side, I had a lot smaller area, so my pressure went way up whenever I was stabbing him with it.
Pressure. Hey, eyes, okay? Got this? Amanda? Colton? Yeah? Eyes, please. Thank you. During a collision, we have a new equation called FADAT. That means force times delta t, where the change or difference in time, equals delta P, or the change in difference in momentum. And Zoe, why don't you tell us how the change in time affected our fight today?
Okay, whenever you were using the boxing glove, it has a whole bunch of padding on it, and so your change in time is going to be more, and so the force is actually less. As compared to the frying pan, there is no padding on it, so when it hits you, you're going to have little to no change in time at all, so the force is actually going to go way up.
Interesting. Alright, so this is how I'm going to eventually calculate the force of my punch against the punching bag. In picture 1, we have me right before I punch the punching bag. The punching bag weighs 45.4 kilograms. The weight of my arm and a little bit of my shoulder is 14 kilograms. And in between picture 1 and 2, momentum is conserved. Picture 2, this is right after I punch the punching bag, right after I make contact. And so before and after, right before and after the collision, this is conserved. Now, in picture 3, we have the punching bag at the highest height that it reaches in its swing. And from picture 2 to picture 3, mechanical energy of 2, mechanical energy of 3 is conserved. Since here we only have kinetic energy and here we only have potential, we can sum that up into Ke of 2 equals Pe of 3. And then up there.
Alright, here we have kinetic energy equals 1/2 mv squared. And down here we have potential energy equals mgh. And now because of this, we set them equal to each other, the masses cancel, and then we solve for v, which equals radical 2gh.
Then we can take that all the way back and plug that into a momentum equation where we have mass of my arm plus the velocity of my arm plus the mass of the bag plus the velocity of the bag equals the total mass and its velocity. Now since the velocity of the bag at the beginning is 0, we can just cancel that out, it's irrelevant. So then we have mass of my arm times the velocity of my arm equals the mass of total times the velocity of this picture over here. Now since we found that out, we can plug in radical 2gh for velocity, and then we can divide out the mass of my arm, put it over there, and we end up with the velocity of my arm equals the total mass times radical 2gh all divided by the mass of my arm. Remember in our derivation we found that velocity of my arm is the mass of the total times the square root of 2gh all divided by the mass of my arm? Well, here are some correct numbers.
We found out the mass of Christian's arm was 14 kilograms. The mass of the bag is about 45.6 kilograms, and the mass total is 59.6 kilograms. And from the video, we measured that he punched the bag up 0.07 meters.
Thank you. So, we're going to plug that in. Equals 59.6 kilograms times 2 times 9.8 meters per second squared times 0.07 meters. Calculate this, Shane, please. Thank you, dear.
Read it off?
Yeah.
Make the bar go longer.
And then...
No, read it off.
No, just look, because I just got done saying it.
It's upside down.
Are you joking?
Should I stop recording?
No, don't. And why would you even... You're such a bad actor. Like, you're awful at this. Just keep it rolling. We've done so many takes. It's just... At this point, I'm just done.
Continue the bar.
Okay, and then... The mass of my arm, it's all divided by the mass of my arm, which is 14 kilograms. Not going to find its velocity of my arm. All they see is grunting. all they hear is grunting in the background.
And they can't see Zoe.
Yeah. Who's that girl with
But
the...
I got that.
So, from our calculations, my arm was moving at 4.98.
That's a 4.
Yeah.
Really, Zoe?
You're not allowed to
4.98
talk.
meters per second. Close it.
His penis is really good.
Here we have FATAP, and we're going to apply what we've done in the previous couple slides to the equation FATAP to find the force of my punch. Here we have the difference in momentum, of momentum final minus momentum initial. Then we have the mass of the total times the velocity final minus the velocity initial. Why don't you cover the rest, Zoe?
Okay, for the mass of the total, it's going to be 59.6 kilograms because it's the mass of Christian's arm and the bag combined. And the final velocity of the punching bag is 0 because it comes to a rest. And the initial velocity is 4.98 meters per second. And then whenever you divide that number by 2 seconds, you get 148 newtons. And it's negative because the force of the bag equals negative force of his arm.
What is love? Baby, don't hurt me. Don't hurt me no more. Baby, don't hurt me. Don't hurt me no more. What is love?
You know, maybe I should keep the beard. I don't know if I look good in it, but hey, it doesn't matter.